Hey, this is Mark, and tonight I'm going to be picking back up where I left off the other day on this iPhone SE. Um, so let me just take a second to make sure the streaming is working. Yes, that's working now. All right. Hey, what's up? Fixing things for you. So yeah, the other day I was recording a few different things, and the last thing was an iPhone SE that had liquid damage and some pretty obvious signs of previous repair attempt. Like this stuff was all screwed up in here. Everything was touching each other, and there was still like a bunch of chips on the board with corrosion under them. And where we left off was it was after prompting to boot, it would pull about 250, 260 milliamps, and then just sit like that. And it seemed like PMIC was getting hot. So that is very likely a red herring. I don't think it's likely to be PMIC. So what I'm going to do is just really start probing around at random, just to see if anything jumps out at me as being short. So what I'm looking for is like a line that's full short. I'm probably going to run across a couple. I don't have all the SE lines memorized, but I'll probably run across a few that have a low resistance to ground, which I'm just going to ignore. For now, I'm going to assume that those, if it's like 0.05 or 0.03 in diode mode, I'm going to assume that it's a high amperage, low voltage line like CPU, SoC, or GPU. So I'll ignore it. What I'm looking for is full shorts. So short beep means I'm getting a reading that would be, the equivalent of like 0.1 or higher in diode mode. So I'm not even looking to see what these are. I'm just looking for those short beeps. All right, there's two long beeps. And that's 0.000 on both sides. So we'll look that line up. I'm going to keep going. So this likely on the same line. All right, and these two guys are short. They're probably on the same line too. So I've got these two and these two out of this kind of big group right here. So I'm going to pull up ZXW and see what lines those are. Sorry, let me get it up here. All right, so these lines here, oh look, that's all, every single one of those is PP3V0 NAND. All right, so now what do? I've found that I've got a full short on PP3VO NAND. It goes to a few different caps and the NAND and the PMIC, and it's kind of in the general vicinity of where PMIC was getting hot. So where do I go from here? Let's see. Just pulling the chat back up so I can keep an eye on you guys. So what I do from here is I inject voltage into PP3V0 NAND and see, does something get hot? So I'm gonna solder a wire right to the ends of these guys here. And going to connect my DC power supply set at 4 volts. And I'm pulling 1.8 volts at 3 amps immediately. So I'm going to feel around where ZXW said there were caps, and definitely getting hot right here. It's very, very, very specific pinpoint of heat. So what do these guys look like? Which one of these is my candidate? One looks pretty much okay. The other one completely looks like shit. So I'm going to pop this guy off. And I know, because people always mention this, yes, I'm just knocking a cap off, and I'm going to fucking ignore it, because all I'm really concerned about with this phone is getting data off of it. And even if data wasn't my concern, you know, it's the purpose that cap serves is not, the function of the phone is not dependent on that capacitor, and removing it is not going to have any noticeable effect for the end user. I know you armchair electronics majors out there are going to, you know, tell me that I'm wrong, but the real world says you can knock that fucking cap off and nobody will ever have any idea it's gone. Alright, so now let's see what diode mode is. Now that I'm done ranting, let's see what diode mode is on that line. Turn the multimeter back on. 0.4, so I am happy with that. So let's see what it does now on the DC power supply after prompt to boot. Use my fuck tweezers. Okay. Great. What I'm getting is, let's try it again just to be sure. Where did I put my good tweezers? There they are. Yeah, 0.7 amp draw after prompt to boot. And it just sits there at 0.7 amps. So that tells me, one, that I need to make sure that my PP1V8 is present. And I'm going to check chat. Let's see. What am I wrong about, Chris? Do tell. Okay. What was I doing? Lost my train of thought now. I am, oh yeah, got to make sure my 1.8 volt is present and that my I2C communication lines for the SE are there. It was 0.07. So that is, that tells me probably I2C line down. I see that very common if the data side of the I2C communication lines are down. I squared C, whatever. All right, so let me find my SE schematics. Or I could just poke around in ZXW until I find it. There we go. All right. So PP1V8 goes to a lot of these caps in here that I've already probed for full short. Now I'll see what diode mode is on them. So this one in particular is a PP1V8 cap. And that's 0.251, which I feel is probably good for PP1V8. That's weird. ZXW has these pads switched. It's got the ground pad up here, and yeah, so that's why you don't always trust ZXW. There's a lot of little things where it's wrong like that, and if you're not on the ball, you might miss that kind of stuff. So now that I know that that line is pretty much, you know, it's got a good diode mode reading, I don't suspect a short on it. So that means my I2C lines are going to be getting the 1.8 volts that they need. So what I'm going to be looking at is resistors that got hit with liquid. Like this guy here, you know, he looks pretty bad. So I'm gonna remember him, put him on my list of things to look at, and keep looking for anything else. I'm gonna remember this guy. Let's see, what else? So on these data and clock lines for the I squared Z communications, they have pull-up resistors on both lines. And they don't tend to have any filters. They'll have some small caps, but you know, really the way to quickly narrow down, there's another one, quickly narrow down the possible causes is to just visually identify resistors that look like shit. Like, he's encased in flux, but I think he looks pretty bad too. So rather than tracking down all of these data lines and clock lines, I'm going to just look at the places I can see damage and hopefully get to the solution a lot quicker. One thing that concerns me is this signs of excessive heat right near TriStar. You know, that tells me that it's possible that there could be a short under TriStar because of the underfill and because it hasn't been changed. So I'm going to look into the resistors first, though. All right, so let me pull up ZXW and see which of these guys I need to worry about the most. Let's see, what's this guy by front camera? So this is on a RF line, radio frequency. I don't expect that to be one of the lines I'm really worried about. Yeah, PP PN66 SIM PMU. I'm not gonna worry about him. Let's see, what was this guy? Which one was it? Yeah, the third one up. That is, what line are you? PP1V8 SD RAM. Okay, and then on the other side, PPWLAN. So maybe, I don't know. Might as well check what the diode mode reading is on PP1V8 SD RAM while I've got that point in front of me. 0.5 on that line. All right, and then what was the third one that looked like shit? It's down here, wasn't it? Where did it go? Where the hell was it? Oh, this guy. Okay. So it was the middle one? Yeah, the middle one. That's PMU to Stockholm and PP1V8 SD RAM. All right. Let's go back to the camera. All right, so I don't know. I don't think any of those are good candidates for the 70 milliamp, but this one did pop off when I probed it. So it's a 0 ohm resistor, and I'm just going to pop a little jumper on there. It does only go from like SD-RAM to Wi-Fi, so I don't really think it's necessary, but since it is, you know, just all it takes is placing a jumper, it's a 0 ohm resistor. I'll go ahead and put a jumper on there real quick. And then I can pull up the schematics and actually find these I2C lines. This phone, I knew it was going to be a nightmare the first time I looked at it, and I'm starting with it tonight because I I quickly probed around and noticed that 1V8 short, or the 3VO NAND short, and wanted to kind of go over that rather than continue working on it. I don't really expect to solve this one tonight. Phones like this will usually take a few sessions when they're got obvious signs of somebody else's work that I have to be concerned about. So I'm going to put a little bit more time into solving this and then move on to the long screw probably. Alright, so next step is pulling up the schematic and, oh, Nate Parker, $5, awesome, thanks man. See, after seeing your last stream and how you solved them, I was able to fix a 6S Plus. This is the most difficult job you've solved. Well, great, man. What was the problem? How did you find the fault, and what was it? What did you do to solve it? You can tell me that while I'm trying to find where I have these schematics. Let's see. iPhone SE. Actually, I think I can just do this in ZXW. That might be quicker. Let's see, pull down the list of lines and find the I2C. Let's see, and I'm looking for the I2C to AP lines. Those are the ones that I'm concerned about right now. I2C0, I2C1, I2C2. All right, so let's see. That one goes to PMIC and Chestnut and backlight driver and CPU. Let's see, does it go to TriStar as well? No. All right, and its resistor is on the top of the board right there. So let's have a look at that. That resistor was, I believe, this one. Double check. Yeah, so probe that in diode mode, see what do I get? $252 on one side, $335 on the other. I feel like that's seems pretty normal. So move on to the next. That was the clock line. Now the data line. This guy. 330 and 252. I'm okay with that. So let's see, I2C1. This one goes to PMIC, CPU. This little chip that I forget what he does that's already off the board. And then TriStar and Tigris. All right, so where is your resistor? You're on the back of the board. Right there. Dig this guy out. $250 and $325. Good with that. All right. Next, the data line for I2C1. It's this guy. $325, $251. Moving farther down, I2C2. Back to the top of the board. And it is this guy. $250 and $330. And the data line. It's this one. $320 and $250. And this brings up a good point. You might not notice this, but this bracket right here is actually isolated from ground. Ground is not connecting to the bracket itself. So this bracket isn't actually grounded until the phone is fully put together and the shield is in. And then everything is grounded once the screws are in. So taking diode mode measurements with my red probe on this bracket gives me no reading. So like for a second there I thought, wait, that's not right. But then I remembered that not all of these brackets are grounded. So it's a good habit to get into, to use things like these solder pads that are always on ground, or I like to use the SIM tray just because it's a big, easy spot to keep the probe on, even if it slips a little bit. Pick away some of these balls from the guy that mangled the board before me. All right. So no luck there. None of those lines seem like they're low. And there's no corrosion at any of the resistors. So then I guess the next most common thing I would suspect would then be perhaps TriStar. It's definitely something to rule out before moving on, but I don't think it's what I'm going to do tonight. I'm going to move on to another repair and put this aside for another revisit in the future. So, made a little bit of progress, but sometimes these take a few sessions, and I get tired of working on the same thing pretty quickly. All right, let me pull the stream back up. Let's see, did Nate ever tell me about his repair? Games for Life asks, Mark, do you provide repair services? Yes, I do. Go to the website that is right here. Go to that site right there, and that's where you can request a repair. Let's see, Chris Long is asking, how often do you fix 0.07 draw when I2C looks okay? Also, how would you approach bouncing 0.07 on and off? All right, so the bouncing on and off, oh man, it's one of those things that's like on the tip of my brain, what I've seen recently that was doing that and how I solved it. And now it's driving me nuts that I can't remember what device that was and what the solution was. This happens so much. There's so many things I've fixed, and then when I see them again, I'm like, how the fuck did I do that? So I don't have an answer on the bouncing 0.07. Yeah, that I would have to think about that for a little bit, but I know I've even recently solved one that was doing that. Okay, moving on. How often do I fix the 0.07 when I2C looks okay? I don't really want to put a percentage on that, but maybe like half of them, a little better than half. And you know, it ends up being like some other chip that's causing a problem. You know, a lot of times it's TriStar or it can be Tigris. Okay, move on. Let's see, fixing things. Oh yeah, Nate Parker, 6S Plus came to him dead. His PortaPow is not showing full boot power, and the DC power supply would ramp up and then settle at 300 milliamps. Found it had a partial short to ground on VCC main. Well, that is awesome, man. I'm glad you're able to figure that out and solve that, and glad any advice I gave you helped. It feels good to fix stuff like that. Let's see, you've got a 6S doing the same as Chris's. Got a 5 that won't read gas gauge. And you're thinking PMIC. No, please no. God, no. You're not the first person who I've heard say that kind of thing. But it's not going to be PMIC. Gas gauge problems, and that's a 5. That's going to be like your battery or the filter on the board. I mean, 99.9% of the time in a 5. So, you know, make sure you've ruled those out. Make sure you're using known good and not assumed good parts when you're testing. And make sure that you're confirming gas gauge errors using something like iBackupBot or 3U tools that can read the real-time logs. Let's see. Nate Parker says, turns out somebody had already worked on it. Looked like they dipped the board in flux. There was so much. I found corrosion in several places. Pulled an IC like you did on the last stream. All right, excellent. Yeah, so the corrosion under chips is, especially in liquid damage, if you see a partial short on VCC main like that, a low reading that may not be a full short, that's going to be your first thought, or it should be your first thought every time, is corrosion under a chip. All right, so moving on. Get back to work, Mark. Yeah, iPhone 6, long screw damage. Pretty classic stuff. This hole's good, this hole's good, this hole is fucked. So I'm going to pull the shield off and just kind of do my thing. All right. And I do also have an S6 that I'm going to do a chip-off data recovery on. once I'm done doing all, this long screw, and I'm going to do the 5X battery FPC. And then I'm going to take a break for a little bit and come back on the official iPad Rehab channel and do the S6 chip off. So I'm gonna skip describing everything that I'm doing for this repair. I'm just gonna kind of do it and get it done, because anybody that watches videos on my channel has seen me do this and describe it at least 50 other times. Oh, that's the worst. I really hate it when these guys come up with that top layer. Ugh, so annoying. That means this just turned into one of the pain in the ass 6 long screw jobs. I'm going to trim this back just a little farther because I think I might need it. Alright. Fuck. Hate it when this happens. So annoying. Dig these guys out. Alright, just stick to something. Alright, there you go. Move that guy there. Need to tin these tips a little bit better. Alright, got the little diode turned so that he's off of his one pad but still connected to that same line that runs to that pin. And now I can pull that trace up and dig out underneath it. And this is my payback for that easy Samsung I got the other night. This is the universe saying, oh, fuck you, Mark. You don't get to have easy nights 2 nights in a row. Alright. Just trying to peel this guy up a little bit and just fold him over out of the way so that I can get to, look at how that's delaminated all the way up under there. See, there's really no avoiding those traces being damaged like this. You know, it's just, some of them are like this. It's what makes 6 long screws so difficult, is that you find damage so far out from, you know, like this is where the screw hit, and damage is way over here. Miss those old 5S's with just the cut traces. Like those. You guys should send me some of those. No repair shops should ever fix those 5S long screw damages. You should just send them straight to Mark. Don't even bother touching them. But if you want to try fixing 6 long screw damage, by all means go for it, but I won't touch it after you have. Alright. Oh, you little fucker. Oh, this is how it's gonna be, huh? That guy has already lifted off the board so much that just the little bit of touching I've been doing, he is really unhappy about. Alright, so we're going to lose this trace entirely and replace it with a jumper once I'm done. And I've lost my filter over here, so I'm going to have to grab one off a donor board once it's time. But this does make it a little bit easier to deal with these guys. Okay, I think I'm done there. Let's see now. Am I gonna have to dig out this via? Because I kind of feel like I'm gonna have to. Look at how spongy that is. I don't think there's any avoiding it. Yeah, this is the top of the via here. Right there. Maybe it's okay. I'll try a quick diode mode reading. It's hard to tell with this if this is separated from the third layer or not sometimes, because just probing it can cause enough pressure to make it connect again. But that's a very light touch, and I'm getting a diode mode reading, so maybe I'm lucky there. I'll give it a try before I decide that I've got to go digging farther. All right. These guys seem okay. Hopefully Wi-Fi is going to be fine. Alright, I think I am ready to start laying down the traces now. I miss being in New York and having somebody that can keep an eye on the chat while I'm working. I feel like I should be paying attention to you guys that are taking the time to watch me stream this, but I can't really get this done and read the chat constantly, so sorry. Oh, hey, that's my little filter that I lost. It's okay, little guy. I got you. You just stay right there. Oh, gotta be careful not to pinch this wire too tight. The best tweezers for the job, the finest tipped tweezers whose points come perfectly together, are a blessing and a curse, because those are the tweezers that are going to be easy to pinch these, this 45 gauge wire and cause it to break, which is not that bad right now, when like I see it happening and can address it, but it's kind of annoying when you find, like, after the repair is done that, oh, nope, it's not actually working, and it's because a line was broken that didn't look broken. All right. That first trace was not uncovered well enough. All right, 3 down and 3 to go. Now this last one is going to be particularly difficult because there's not a lot of it sticking out. Well, not last one, next to last one. All right, that seems like it's on there. Okay, every trace is repaired. So let's do a little cleanup, have a look at things, and test. All right, nobody's touching each other. Everybody looks well connected. Not going to worry about that ear speaker filter just yet. I just want to see if this will boot. I want to see it boot, and I want to see it have touch. All right, I've got nothing. Not certain that that battery is charged, and I have the DC power supply right here, so I'll just connect this up and let's see what it does on DC power. It does nothing. Oh, I gotta plug that lightning cable in if I want to prompt to boot that way. What the hell? Is this cable no longer good? Maybe that charging brick is not good. Alright, well, for now, I will just prompt to boot like this. So it looks like it's booting normally, but I'm still getting no image. So let me probe these guys. I got 0 volts on that line. 0 volts on that line. So 0 volts on LCM reset and 0 volts on LCM enable. So, let's see what I get in diode mode at the connector on those lines. I think it's this guy and this one. Pretty sure that shouldn't be short to ground. Yep, that is short to ground. So what have I done? What have I done here? Is it over here? Is this where I'm short to ground? I don't know. Weird. Not short to ground there. I bet it was just this kind of touching there. I'm gonna solder that a little bit better. I should have caught that when I was listening earlier. That's kind of a shitty joint right there. All right, that seems to be better. Okay. Is there short to ground now? No. What about at the pin? Nope. Okay, let's try this again. So again, looks like it is booting, but I'm getting no image. So back to voltage mode. Let's see if these voltages are present now. Got 1.8 there. Got 1.8 there. It's definitely no image and not no backlight. So I have both of those 1.8 volt lines. Got the 5.7 volt line. Why you gotta be an asshole, phone? Well, the only lines in any of this that have to do with image are this short one here and this one that runs over here. And this one runs directly under CPU, so it doesn't go, there's nowhere to tie into that line from here besides following it towards CPU. And that goes down into the third layer. So I do have 1.8 volts there, so I don't think that that line is my problem, but it could be that there's a partial but bad connection. So, you know, like I'm seeing 1.8 volts, but, you know, at the CPU end, it may be seeing like 0.5 or 0.6 or something, because it's still making partial connection in there, but not fully connected. It is a little bit spongy. But before I go through the trouble of digging into third layer, I just want to rule out a couple of other possible no image faults, which are not going to be likely that there's you know, multiple problems causing no image, but better to use the multimeter and rule it out first. I feel like this guy should not be open line. Yeah, so that is definitely one of the 5.7 volt lines. Let's see, pull up ZXW and see what line that is. PP5B7 LCM. So I'm getting open line there. That runs over to a filter, some caps. Also has some caps on the back of the board. And I know that that line also is this guy. Oh, let me switch. Whoops. Didn't switch back the camera. All right, so yeah, that line runs to this filter, these caps, and then to this kind of fat trace that's over here. This guy. So let's see what I get for diode mode on him. 525, which is as it should be. Ah, well, there's your problem. I nicked that guy when I was cutting the top layer off. Whoops. Oops. Good thing I know how to fix that. Even I fuck up sometimes. I mean, of course I fuck up. Everybody does. The trick is to know how to diagnose and correct your fuck ups. That's what separates the good ones from the bad ones. And it's a damn good thing I thought to investigate further before digging into that third layer, because now there's still a chance that I won't have to. And I'm all about not digging into the third layer if possible. Okay. Now, are you gonna work for me? There we go. Yay. All right. Image works. Touch is definitely going to work. There's no way touch is not going to work. This is going to be perfect. I'm going to move on to a stupid, simple battery connector, and then I'm going to get a break. So just going to check back through the chat. Jonathan Dix is asking, with Samsung chip off recovery, does that work 100% of the time? Switch this over to the battery. It doesn't work 100% of the time, but it does work very, very often. There's a couple of cases where it won't work. One would be if sorry, drawing a blank. S6 data recovery, if they've upgraded Android. So the S6 isn't going to come with the Android, I think it's Android 6 and higher, that has encryption enabled by default. So if they've upgraded, they get the option to opt in for that, and if they have, then you can't do chip off, and you shouldn't even attempt to do chip off, because the only path to data is getting that board to boot up and work. And then the other cases that it doesn't work is if the fault is in the NAND or the UFS chip itself. And I've seen that a couple of times. I wouldn't say it's common, and it seems to follow the same kind of pattern of symptoms. So I wouldn't call it a signature failure for the S6 that the memory fails, but it has happened, and it does happen. But for the most part, I would say I've had as much success with the S6 chip off as I have with the previous like eMMC that all of the cheap phones have, which is very high, like 90s, somewhere in there. Let's see, going back through chat. Chris says DeddyProg determined his reader and socket to be faulty. Oh, no fucking shit. That's awesome. I bet you were really happy to hear that. Like, oh, really? The thing that I have been telling you is not working? You agree with me now? Great. Thanks, guys. All right. I'm getting way off track here. let's see. Prompt this guy to boot again on the battery. And now you're not booting in. God damn it. You son of a bitch. Alright, what are you doing on DC power supply? Why do you gotta do this to me, you bastard? Booting normally on DC power supply again, but still got no image. So which one of these guys is my problem here? One 1.8, 1.8, 0.2. Why is my 5v7 at 0.2? That makes no sense. What do you look like in diode mode? 5v7 LCM. $280. That's not right. Do I have that bridged in here? Okay, try this again. There we go, 480, that's much better. Alright, you're gonna fucking boot for me this time, you little bastard. And I'm gonna slap some goop on your traces so you don't fuck up again. Battery back on. There we go. All right, back to the chat. Let's see. Yeah, Aaron says, unless the chip is damaged or the data is encrypted, it should work nearly every time. Yeah, that's right. I mean, those really are the only two options to failure is either the chip is damaged or the data is encrypted, or, you know, if your reader is faulty, that'll cause problems. Or if your chip is not like reballed perfectly, you know, you can have bad connections. So touch is working on this. So I'm going to say this is good to go. Put that aside and do the cleanup and green goop a little later off camera. And move on to the last thing I planned to do tonight, which is this Nexus 5X Battery FPC. Look at that. That fucker got wrecked. So, looks like a pad is missing that has a VIA, and it's possible that it could talk to this guy, which would be great, but it doesn't. So, let's figure out what it does talk to. Does it talk to here? No. Does it talk to here? No. Does it talk to here? No. Do you talk to here? No. Here. Yay! Alright, so from this test point, that's where that VIA talks to. So that pad is gone. And that's either going to be the temperature or gas gauge line. This is going to be, the other one of those two, temperature or gas gauge. And then we've got our positive and negative on the outside here. So I'll just run a short jumper over to that test point, and that's all that needs to be done once I take this connector off and put a new one on. Look at chat again. What model of the tip on your Hakko tweezers? My Hakko hot tweezers, I use the I shape. So it's, I forget what it is, if it's the T9 or T30 that goes in these. I always get those two mixed up. I can never remember. One is the micro pencil and one is the mini hot tweezers. One of those is T30, one's T9, and both of them I use the I shape. All right, got to stop talking while I'm working because I'm forgetting what I'm doing. So I'm going to tin these up with some leaded solder. All right, let's see if I can maybe just pull this pin right off. There, that was easy. Now I can probably get these guys off. Ground's going to take a little bit more. There we go. All right, so I will get rid of the solder on there, clean that up. And now I've got my donor board. This is a perfectly working Nexus 5X that is being sacrificed for the greater good because I could not source this connector. So I want to get this guy off without melting him, and he started to melt. So I'm going to take that as a sign that I need to do something a little different. In this case, I'm going to go ahead and tin these joints up with leaded solder like I did for the one I was removing. That'll help it come off a little easier with a little less heat. So I want to try and get as much leaded solder mixed in there with the lead free as I can to reduce the melting temperature of the alloy as a whole. All right, now let's see if I can get this off without melting it. Let me go ahead and turn my air temperature down a little bit. The temperature I turned it to is 20 degrees lower than the temperature that it was at. And the temperature that it started at was hot enough, but not too hot for most jobs. But it happened to be too hot for this job. So, for those of you out there who are planning to ask me what the temperature I use is, that's it. All right. So that is not ideal. That was me not paying attention and talking and not really paying attention to what I'm doing, and I lifted the connector off the board while I still had the hot air on it. And I know that that is a big no-no because I teach people not to do that every month. In fact, this time next week, I'll be prepping for our next practical board repair class, where I will spend all of the whole week saying things like, don't lift the connector off the board while you've got hot air on there. But I think this is still salvageable. It's going to have to be because it is the only one I have. All right, now for the jumper. Let's see if I can get rid of that little bit of plastic that's in the way there. All right. So I think this is still going to work just fine. Looks like I deformed the plastic very slightly, but the pins are still fine, and the shape of it to receive the plastic of the other half looks like, the interior shape still looks the shape that it should be. So I think it'll be fine. I am going to connect a battery though, just to see if it does snap in there the way I want it to. Oh yeah, that's just fine. Nothing wrong with that. Where'd it go? Trim off the extra. And I will go through and catch up with whatever you guys are talking about in chat, and then I'm going to take a break. Chris Long responds with T9I. There you go. I should have just read the very next line, and then I could have avoided trying to think of it and ranting about it. Just fix. You had a brand new battery for this 5. You just tried one from the dud phone pile, and it's charging full current. Yeah, so there. I hope that the lesson you've learned is new is not the same as known good, and that is also something we stress very heavily throughout the course. Is a lot of technicians are in the habit of grabbing new parts to test with, and that's fine for most of the stuff in the shop, but when you start applying that to board repair, you want to make sure that you really only ever use known good. And I will often test my known good parts with known good boards before I start working on a bunch of things, just because known good parts turn into known bad, and new is never known good. It doesn't turn into known good until you've seen it work and do whatever it's supposed to. Battery charge, screen turn on, all that. Let's see, anything else in chat I need to respond to? All right, doesn't look like there's anything else I need to get back to with chat. So yeah, thanks for watching, guys. I'm going to end this. I'll probably hop on the iPad Rehab channel after I've had a bit of a break and do this S6 chip-off job. So I just need to go through and make sure I have the software set up and working on my desktop here. I usually use a dedicated laptop for this recovery stuff, but since I'm going to stream it, I'll go ahead and get it worked out so that I can screen share. All right, Nate, thanks for the beer money, man. Have a good night.